So, hi everyone, and welcome back to Trigonometry after our little break. And I want to talk today with you about trig equations. And when it comes to the trig equations, I've got a ditty. And the ditty goes like this. To find an angle, draw a circle. To find a ratio, draw a triangle. To find an angle, draw a circle. To find a ratio, draw a triangle. A angle goes with C circle. R ratio goes with T triangle. Now, how do you know if you're looking for an angle? Well, maybe they're saying find theta. That's a good clue. Or you'll see things that look like angles. What looks like an angle? Any arc trig. Arc sine, that's an angle. That's theta equals that arc. That's the angle with the sign of. What looks like a ratio? Any trig function. Sine of, cosine of, cosecant of. All of those are ratios. Arcsine, arctan, inverse secant. All of those look like angles. And that's how we tell the difference. Okay? Now, so let's go ahead and grab one equation. And this one's fairly typical in the sense that I'm going to be looking for all the solutions in this region between 0 and 2 pi. 0 to 2 pi means any solution along the unit circle. Okay? If I'm graphing it out. All the solutions there are going to be in the unit circle. Between 0 and 2 pi, the first revolution. So let's go ahead and take a look at this. 6 sine theta plus 6 equals 9. And this is fairly simple. It's just a linear equation in sine theta. So let's hit it. Solve 6 sine theta equals 3. Bringing the 6 over. Sine theta equals 1/2. And when you see sine theta equals 1/2, everyone should say, yup, I recognize that. That's one of my principal ratios. And more than that, because I'm working with sine, I know the other ditty, right? First step, you're halfway there. Sine of 0 is 0, and then your first step past that, you're halfway there. And the first step past 0 degrees, or 0 radians, is 30 degrees, which I think of as pi over 6 radians. A number right around a half as well. In any case, I'm going to do this really formally for right now, just so that you can see how it actually works. And so to do this formally, I would write arc sine of the sine of theta equals arc sine of 1/2. And then formally, I would notice that these two are inverse functions. That's why I'm hitting both sides of the equation with an inverse function, and use the fact that inverse functions cancel, which gives me a solution for theta. Okay? I want to remind you guys that arc sine is the angle that has a sine of 1/2. So anytime you see arc sine out in front, you know you're looking at an angle. If I see sine out in front, I know I'm looking at a ratio. This is a ratio. This is an angle. Okay. Now, arc sine of 1/2. Arc sine of 1/2. So everybody thinks pi over 6 or 30 degrees, hopefully because they remember their grid. Okay? But let me go ahead and remind you guys what was the ditty. The ditty said, to find an angle, draw a circle. And so I am going to draw a circle. There we go. Pretty little circle. Put some axes in here so I can see it. Now, I'm going to go find my solutions on this circle by using the fact that I have a sine. I'm looking for the arc sine of 1/2, right? Now, sine is an X thing or a Y thing, guys? You can answer me in the chat. Sine is an X thing or a Y thing? Everybody says Y thing. Yay! That's awesome. And so I'm going to find Y is equal to 1/2 on my graph. 1/2 is right here. Okay. And now I'm going to draw where Y equals 1/2 all the way across. Oh, look. It hit two places. Once here and once here. And this is totally typical. What's usually going to happen is that when we have these, if I'm looking for the angles, the solutions between 0 and 2 pi, in other words, if I'm looking for the solutions on the unit circle, I'm usually going to get two solutions. Okay? So here I see my first solution is that pi over 6, because I know it's a principal ratio, right? And first step, or you think of it as 30 degrees, yeah? Now here's the other one, and I can ask myself what it is. I can eyeball this, and I can recognize it's the supplement, the 180's complement. And the 180's complement, we're looking at 150 degrees. Okay? At 150 degrees. That's 30 degrees short of 180, right? Now, when I'm looking at the radians, 6 isn't natural until you write always pi is 6 pi over 6. And when I write pi at 6 pi over 6, then I'm seeing 1/6 less is 5 pi over 6. And that's the easy way to see it. Okay? In any case, 150 degrees or 30 degrees are the two solutions on 0 to 2 pi, which is the way you're normally going to be asked for it. Okay? If I wanted all solutions, I would start with those two. All solutions, all real solutions, I would start with those two. And I would say pi over 6 plus its coterminal angles, which are given by multiples of 2 pi or 360 degrees. 2 pi n. N means a multiple of 2 pi is the full way around. That's 360 degrees. And the other solutions are 5 pi over 6 plus multiples of 2 pi. 2 pi times n. And here, just n is just any whole number or negative whole number or 0. At 0, I get the pi over 6 and 5 pi over 6 that you're seeing. There's the infinite number, but as far as between 0 and 2 pi, I'm normally going to get just two solutions. Okay? So that was pretty easy, I hope, right? Yeah? Okay. But now I need to do more problems, so let's do more problems. Okay. For our next example, I always go back when I'm solving trig equations to remind myself if I need to find an angle, draw a circle. And to find a ratio, draw a triangle. And that's my ditty for this. Okay? My next equation that I'm going to be looking at right now is this one. The example is 1 minus 7 cosine theta equals 8. And I want the solutions for theta between 0 and 2 pi. Now, when they say 0 to 2 pi, you know your answer needs to be in radians. If they say 0 to 360 degrees, then they don't want the answers in degrees. Okay? And by they, I mean me. Or whoever's writing the software on the problem that I was setting for you. Okay? So guys, what are we trying to solve for, guys? Angular ratio. Anybody? What am I trying to solve for? Am I trying to solve for an angle? Yeah. Now you see, I'm going to end up solving this equation for cosine theta, but that's not a solution for anything other than cosine theta. I'm looking for theta in 0 to 2 pi, so I'm going to be looking for an angle, and that's implied in here. Yeah, I want to find this theta. That's implied by the way it was written. Yes, angle. So, let's do it. I get -7 cosine theta equals 7, subtracting 1 from both sides. Okay? And then, this gives me cosine theta equals -1. All right? So here we go. I could finish that last bit. I could talk about theta being the arced cosine of -1, and that works. But as soon as I see the cosine theta equals -1, I know I'm trying to solve this for theta. It's the only variable up there. Cosine's not a variable, it's a function. Okay, so I'm trying to find an angle. So what do? I draw a circle. So let's circle. Here we go. Now remember, we normally expect to get 2 solutions, right? I'm expecting 2 solutions. And now I ask myself, cosine, is that an X thing or a Y thing? And by asking myself, I mean asking you. Is cosine is an X thing? There we go. Yeah, great. Okay. And so I'm looking for cosine -1. Cosine is negative. I'm looking for where X is -1. That's right here, isn't it? Oh my. But if I'm looking just for the places where X is equal to -1, that's all these places, isn't it? So I'm going to draw that line where X is equal to -1. And though I would normally, that vertical line would normally hit the circle twice, here I'm at an extreme value at 1 or -1 on the cosine. And because of that, I get exactly 1 solution. Ah. And that will happen with sine, cosine, secant, and cosecant. Tangent and cotangent will always give you 2 solutions. Okay? Because then we're not going to be doing vertical or horizontal slices. We'll be doing slices through the origin. And any slice through the origin is going to give you 2 angles. Okay? But yeah, for sine, cosine, and the reciprocals, it's possible to get 1 solution. It's actually possible to get 0 solutions. I could have had a solution where cosine theta was equal to -2. But in either case, that's this. Now, if I look at this, again, I can just read the solution off of the graph, right? Where are we at right here? What angle is that? Anybody? I can wait. What angle is that there? What angle is this point on the unit circle? Pi! Yay! See, I was just like hoping somebody would say 180 degrees. So that I could say, remember, we're looking for answers in radians. But yeah, pi is right. Yeah. By the way, if you're on a laptop right there, if you use Option P, not that it's all that important, but Option P, yeah, that's pi. Just one of those things. Okay, so the answer is theta equals pi. And that's the only solution between 0 and 2 pi. If I wanted all the solutions to have multiples of 2 pi, I'd say plus 2 pi n. I could say plus 2 pi n, but there is no value of n other than 0. This is going to leave me between 0 and 2 pi. Okay? So, let's do it again. This time, the slightly different example, where we have to move things around with reciprocals. So my new solution, my new example this time, is going to have a secant in it. 4 root 3 secant of theta plus 7 equals negative 1. It's still just another linear equation to solve. So let's do it. Yeah. First thing is, you solve it like any other linear equation. Anything that's not next needs to go to the right. And plus 7, that means subtract 7 to both sides. 4 root 3 secant theta equals negative 8. Subtracting 7 to both sides. Then dividing by, then I'm going to divide by 4 root 3, which gives me secant theta equals negative 8 over 4 root 3, right? And that looks to me like negative 2 over root 3. Okay, so we're kind of right in there now. That's one of the principal ratios. Probably easier to recognize. Easier to recognize when we go to the reciprocal function. Because you're not going to graph secants and cosecants on the unit circle. You're going to graph sines and cosines. And tangents too, but mostly sines and cosines. So let's turn that around. And, oh, because I'm anal, I'm going to rewrite all that in blue because I just want everything to be blue, okay? Here we go. So again, this gives me 4 root 3 secant theta equals negative 8. Secant theta equals negative 8 over 4 root 3, which is equal to negative 2 over root 3. And now, the reciprocal of secant is what? Tangent? What is it? I forget what the reciprocal of secant is. What's the reciprocal of the secant, guys? Reciprocal of secant. Okay? Remember your grid. Sine, cosine, tangent. Yeah, there you go. Cosine, cosine, cosine. That's right. And over here, everything has to have a cofunction, so this has to be cosecant. And so that's secant and cotangent, yeah? Okay. So here we go. So this gives me the cosine of theta is negative root 3 over 2. Okay? And yay, it's once again a principal ratio. Now, it's not a reference angle because all the reference angles have positive ratios. This is a negative ratio. So in any case, I'm looking for theta. And so because I'm looking for an angle, I'm going to draw what? I'm going to draw a triangle, right? What should I draw? I don't know. I could draw a smiley face. How about that? Oh, circle. Okay. Well, I kind of got there. Let's draw a smiley face. Okay. A circle. So let me draw a circle. Here we are. Now remember, when you're drawing these circles, it's pretty simple. Remember, this is cosine is an X thing or a Y thing? Cosine is an X thing or a Y thing. Which is it, guys? It's an X thing, okay? And I'm looking for negative root 3 over 2. So I'm going to go to X, and I'm going to toss in a hash mark at negative 1/2 always, okay? And then I'm going to split the rest of it into thirds, okay? And that's going to give me my principal non-extreme values. Okay, and that goes from 1 to root 2 over 2 to root 3 over 2. The last one is root 3 over 2. And so that is where I'm going to draw. That's where I'm going to draw my vertical line. At x equals negative root 3 over 2. Now, here once again, I can see on the reference angle over here, the reference angle is once again, that's the small one. That's less than 45, so it has to be pi over 6, yeah? Okay, and so where are we here? Now, I showed you guys how to do this before, right? Since I'm looking at 6, I'm thinking 6, 6 here, right? Yeah, 6, 6 pi, but you think 6, 6. So this must be what? This must be, how many 6? One less than 6, 6? 5, 6, right? Now, I can do clever things by noticing if I have theta here, I'll have pi minus theta here, and I'll have theta plus pi here, and I'll have 2 pi minus theta here. But you can eyeball this, right? If the top one is 1/6 less, if the top one is 1/6 less than 6, 6, the bottom one has to be 1/6 more. So I get 7 pi over 6. Once again, you see, as the usual answer is we get 2 solutions. Because the last one had an extreme value, but this time I get just this, okay? So my solutions on this one, will be theta equals pi over 6, 5 pi over 6, or 7 pi over 6. And again, if I wanted all the solutions, this is all the solutions between 0 and 2 pi. If I wanted all the solutions, I have to add multiples of 2 pi. And you write multiples of 2 pi just by writing 2 pi and then following it with an n. And then you just let n go from 0, 1, 2, 3, and -1, -2, -3 to get the other infinite number of solutions. But generally when I say there's 2 solutions, I mean on the unit circle. Okay? There we go. Now everything I've done so far was with, full angles. Yeah? And now, now I want to look at what happens if we need to have a calculator. So let's get our calculators out, guys. I'm going to have to walk across the room and get, oh, there's my calculator. I've got calculators littered across everything around here, but there's almost always in here. Hi, Lewis. I'm glad to see you entirely. Really happy to see you. And I'm sorry you missed most of this right there, but I'm going to remind everyone here that these lectures will be uploaded to YouTube. We'll talk about that in just a little bit. Again, I'll revise that for anybody that came in late. I'll go back to that first slide. But for right now, I want to talk about solving these when it's not going to be a principal ratio. So let's get us back and start up a new problem for this example. A new example. Recalling my ditty. Of course, everything I'm doing is looking for angles right now, so that's where we're at, right? Okay, so for this example, I'm going to be looking to try to solve secant of theta equals 4.57. All right? Okay. Yeah, last Tuesday's lecture isn't going to have a recording because it was a special session when I was giving students the math behind the COVID virus and projections on that. And it was serious news, and I didn't necessarily want to memorialize that with a video. Okay, so here's the thing. And of course, you don't have arcsecant buttons. I know the answer is the arcsecant of 4.57, right? But on this one right there, the first thing you always just go ahead and translate back to its reciprocal. And now guys, your calculator is going to give you an answer on this, right? I'm going to mention, guys, the answer is the arc cosine of 1 over 4.57. Now, I want my answer in radians. And I want all of the answers on the unit circle. You notice how I write the unit circle right there? I don't want to include any point twice on the unit circle, so I include 0, but I exclude 2 pi, which is a coterminal angle. All right? So this is something you can plug into your calculators, guys, right? So get your calculators out and find the arc cosine of 1 over 4.57. Okay? So you do that, you punch it around right there, and it tells you 77 degrees. And then you remember the professor said radians. And then you move back over to radians. You switch yourself over to radians, and then you calculate it again, right? So what do you guys get when you plug it into radians, guys? Oops, I changed my color. What's your answer in radians, guys? Plug it in. I'll blow it up even so you can see it. I'm seeing 1.350. And more numbers, right? Yeah. Yep. Yep. If you're not getting 1.350, I don't really know what else could go wrong. The only other thing you're going to get is 77 degrees. So there it is. Now, how many solutions do I expect, guys? How many solutions do I expect? Who can tell me how many solutions I'm expecting? 2. Yep, yep. So guys, we're not done yet until I find the other solution. Now to find the other solution, it's helpful to visualize this. So once again, I'm looking for an angle. So I am going to draw a circle. Oops. Amazing how that cleans itself up when I do that. Now I look at the original number, I see 1 over 4.57, right? And cosines, yes? Okay, and cosine is what? Next thing, yeah? And so, if I'm looking for cosine as an x thing, it's around 1 over 4. I'm going to approximate that as about 0.2. So that's kind of right here, yeah? So I'm going to draw a hash mark at like 0.2. And I'm going to extend that. And this is x equals 1 over 4.57. Here's the solution you just came up with, guys. Let me zoom that here so that you don't have to squint too hard. Okay? There's the solution you just came up with. There's the 1.350. And here is the other solution that we need to find. And now if it helps, if we're looking at these all positive right here, if I have an angle theta here, it's pi minus theta here, the supplement. Over here it's theta plus pi. Just add 180 degrees. And over here, it's 2 pi, all 360 degrees minus theta. So for this one, the other one, you need to calculate 2 pi minus that 1.350. Now, all your calculators can have a pi key on it, right? So 2 times pi, and the pi key on the TI-30Xs that I hand out like candy 2 pi minus 1.35. And on the ones they have, it's 4 down from the left is the calculator button, the pi button. And just punch equals. So guys, do that calculation. What do you get? Look out what's the answer on this one? 4.933. Awesome, awesome, awesome. 4.933. Yeah. Right. Okay. So there we are. That's good. And so there it is. There's my solutions on the unit circle. 1.35 and 4.933. Okay. Now I want to, we got 15 minutes, that's cool. Now I want to swap to, wait, stop. Not ready for that yet. Okay. And now I want to swap to one of the forms everybody loves to do on you guys is set these up with quadratics too. So let me do that. And again, guys, yeah, terrible to say it, but yeah, y'all know I have a smoker's cough, so don't be concerned if you hear me coughing, okay? I'm way, way isolated. I've talked to 3 human beings face to face in the last, wait, it's April 2nd, right? So it's been like the last 3 weeks I've talked to. You guys were the last group that I spoke to, other than in person. Other than that, I talked to 3 individuals since I saw you guys last, face to face. That's it. Oh, a lot more than that otherwise. Okay, here we go. So here's my next example, and this is going to be fairly typical of these other ones. So let me just do this one here. Okay, this new example. Here we go. All right, here we go. 2 sine squared beta well, here's the great thing about being at home. I can just grab myself a glass of water. Give me a second here, guys. Yes, I have a dorm fridge right next to my table here. So a glass of water is very close. Oh, that's better. Yeah. Okay, so let me zoom this out so you can see what I'm writing. Find my pencil again. 7 sine beta plus 4. Plus 4. So, this is a quadratic equation. No coffee, professor. Coffee doesn't work like to clear a cough. I need actual water for that. Yeah. So, here we go. So let's go ahead and solve this as if it was, let's bring it back as if it was a quadratic. 2 sine squared beta minus 7 sine beta minus 4 is 0. And this is a quadratic in the variable sine beta. Okay? And you can think of it, yeah, you can think of it. You can think of it as what? 2x squared minus 7x minus 4. That's what x was sine beta, right? But I'm just going to solve it the way I would normally. This one you can actually factor it. I have other problems I would assign for you guys where you have to use the quadratic formula. But for this one, you can just solve it. I see that it's not monic, and so I look at AC. AC is -8. Give me 2 numbers, 2 factors of -8 that add to -7. Someone? 2 factors of -8 that add to -7. I want 2 factors of -8 that add to -7. That should be pretty easy. 2 factors of -8 that add to -7. I can wait. -8 and 1, -8 and 1, negative, exactly, guys. And we use that. -8 sine beta plus 1 sine beta. -4, 2 sine squared. This is the way students usually like to solve this when it's factoring. I have my method that I like better, but this is the one that students seem to like best. And from here it's just grouping. Pull out 2 sine beta, and I get in here what? Sine, that's the greatest common factor of the first two. Sine beta, divide by 2 sine beta, I get -4, yeah? Yeah? Plus 1 times sine beta, -4, and there's the factorization. 2 sine beta plus 1 and sine beta -4. Now, in the normal course of events, I'd expect each of these factors to give me 2 solutions. But in this case, only one of these is going to give me solutions. And you'll see that in just a second. So, if 2 sine beta plus 1 is 0, then sine of beta equals -1/2. Yeah? That should be pretty easy. Bring the 1 over, and then divide by 2. Okay? And that looks like a principal ratio, except negative, yeah? On the other hand, if sine beta -4 is 0, then sine of beta is going to have to be 4. And that's, no, that doesn't happen. I'll graph them both. I'm looking for an angle, beta, and so I need to draw a circle. And I'll draw the circles, but the one circle is going to be kind of weird looking because here we go, right? Here's my circle, and I have to make it small so this even make this work, right? Yeah. Here's one circle, and here's another circle. Okay. And on the first circle, I see sine is a y thing, yeah? Let me find where sine is -1/2. That's right here, yeah? So there's the solutions. And because I know this is principal, it's related to 30 degrees, yeah? Or pi/6. So here's 6/6. So this must be 7/6 pi. This is 7/6. And this is 12/6 over here. So this must be 11/6 pi. And that's how you solve it. That's how you solve it. Okay? On the other one, I have sine is 4. Sine is a y thing, yeah? That puts it way up here, right? No solutions from that half. Okay? So all the solutions on here are going to be given by theta equals, nope, given by theta equals That's 7/6 pi or 11/6 pi. That's all the solutions between 0 and 2 pi, right? And remember, again, if I wanted all of the solutions, I would include the coterminals by adding in multiples of 2 pi or 360 degrees. Okay. And yeah, so if we find from 0 to 2 pi, we have them all as soon as we add all the multiples. Now, for our last little piece of fun here, we are going to put on some speed. And I don't mean just because we only have like 7 or 8 minutes left. I mean speed. As in angular speed, omega. Now remember, we had one ratio, I'm expecting two solutions, two angles. When I have an angular speed, this was all with sine theta, right? I'm expecting two solutions, but if I put an omega in front of that theta, a number in front of that theta, that's going to multiply the number of solutions by omega. Speed is a solution multiplier. And that's how this works. So on this first equation that you're seeing, how many solutions do you expect on this one? How many solutions do you expect? Sine theta equals 0.3. How many solutions? Yep, that's a calculator problem, 2 solutions. Yeah, and we can do that with a calculator. We already did that. Now, ooh, let's make this more complicated. How many solutions do I expect for sine 2 theta equals 0.3? Recognize what the omega, what's omega here, guys? Omega is what? 2. Omega is 2. See the omega? There's omega. This is sine omega theta, as in omega theta plus phi. Okay? And so, and that's the same omega that we had that gave us period as 2 pi over omega. Okay? So, with omega is equal to 2, how many solutions do I expect? I can wait. 4. There we go. 4 solutions. Okay. Now, what's omega in this next solution, in this next equation? That's right, 4, 4, 4. Thank you, guys. What's omega in this last equation? You see it? What is it? What's my solution multiplier on this one? That's a 5, actually. Sorry about my handwriting. That's a 5. Yeah, 1/5. And so I expect 1/5. I expect 1/5 times 2 solutions. Wait, that's less than 1, isn't it? Okay, so here's the rule. If it's less than 1 but more than 0, it's 1 solution. Anytime you get a fractional solution, it's a solution. So if the multipliers work out to 1.1, expect 2 solutions. If the multiplier works out to 0.9 solutions, then you expect 1 solution. In this case, it came out as 2/5, and so I'm expecting 1 solution. I'm going to solve the middle one for the 4 solutions, because that's the only one that's interesting. And I've only got 3 minutes, so there's where we're going to go, okay? And I'm not actually going to solve the middle one. I'm going to solve one with principal angles so that we can be cute and clever, okay? So here we go. Last example for today. Okay. And since I have most everybody here today, I've got 10 out of 13. The one hasn't been missing. Yeah, I know things are crazy right now, but we need to do our very best to try to be here on time because I ended up delaying things, waiting for people to show up. And so now I'm looking at the end of the period and I'm having problems finding it. So here we go, guys. How many solutions do I expect? Somebody tell me in the chat. How many solutions do I expect this time? That's right. And here's how you're going to do this, guys. Here's how we're going to do this. Now, first of all, I'm going to draw the circle. And this is kind of clever, so you'll like this, okay? I'm going to draw the circle because I always draw a circle, right? Okay? And I'm going to draw the circle the way I like it. There we go. And I'm recognize this is root 2 over 2. It's first quadrant standard solution. And so I'm going to plug that in here, right? Cosine is the next thing. So I start at 1/2. And then I bust into the thirds and I go for the second hash mark. And you see immediately the answers are pi over 4, pi over 4, right? And over here I get either negative pi over 4 or, because remember this is 4/4, right? And this is 8/4. So this is 7 pi over 4. Okay? Now these are the solutions for 2 theta. So here we go. Watch this. This is really cool. This is how it works. 2 theta equals pi over 4. Okay? Now here's where you add in the multiples. Plus 2 pi n. Got that? And so theta is pi over 8 plus pi n. That's how you handle the multiples. Ah. Alternatively, theta is 7 pi over 8 plus pi n. Okay? That's if I use the 2 thetas, it goes 7 pi over 4. Okay? And now I just look at the solutions. Because I'm looking at eighths, I see this is pi over 8 plus 8 pi over 8 and 7 pi over 8 plus 8 pi over 8 and now I just start adding. I get pi over 8, 1/8, and 9/8 from the first one. And after that, the next one up, adding another 8/8 is going to take me outside my 0 of 2 pi. On the second one, I get 7 pi over 8, or I add 8ths, I get 15 pi over 8. And there we go, guys. 4 solutions, which is how many I expected, so I'm going to stop. And I don't mean just because I'm 1 minute and 25 seconds past my time, but that's what it was. Okay, as I said before, guys, I will be uploading videos for you guys who came in late, both on Blackboard, off of the Ultra app, and at YouTube at /Professor Jesse N. Okay, I'm going to leave that up there so you can copy it down or whatever. And again, you're free to subscribe. But if you subscribe, you're going to get notifications on the other classes' videos too. Thank you, and you're welcome. All right, guys. I'm looking to do what we have right there. Lewis, if you can stick around for a little bit so I can see what's going on with you, that would be great. And if everyone else could just say goodbye to me. Subscribe means, Joshua, I mean, I don't have anything bigger than an A for you, okay? But you would have my unending gratitude. I would have no my unending gratitude. And if you could bring along like 950 of your friends to get me over past 1,000, that would unlock a lot of other cool things I could do on my YouTube. I think as of now, I got 30 subscribers, and that's about it. My biggest video is like 800 views in there. Anyway, so that's what it is. Bye, Vinaya. I'll talk to you soon. Okay, it was good to seeing you guys. Take care, everybody, but everybody at Lewis. Okay. Bye, Joshua. Bye, JD. Good to see you. I'll have the video for you too. Bye, Anthony. Bye, Randy. Peace, Daniel. Bye, Miguel. Bye, Elizabeth. Waiting for Carlos to check out so I can talk to Lewis. Okay, all those are gone. I don't know what's going on with Carlos. I think he had a bad salute collection. I'm not sure he's even here now. So I'm going to step him out myself. Okay, now he's gone. Hey, Lewis, how you doing, man? I remember seeing your earlier video. Have you got a mic? Oh, wait. Make sure I stop my reading.